Good afternoon, everyone. My name is Jun Yang. Welcome to this session. I believe our session has the longest title in this conference, Using Secure Data Connector to Access Enterprise Data from Google's Cloud. Don't be intimidated by the title. The most complicated part of our talk is the title, which our marketing folks struggled with for quite some time before they settle on 11 words. So, okay, we have gone past now, so it should all be downhill from here on. So in this session, we'll talk about how to use Google's Secure Data Connector to allow access from cloud apps to your enterprise data. Now first, I want to wear the hat of an enterprise developer. I have a question. My question is, how can I access an on-premise relational database from Google Apps? Now, as you understand, as an enterprise developer, I have a lot of relational data in my intranet behind the firewall. But I do want to use Google Apps to get access to them so that I can build interesting apps. Now, how can I access an on-premise relational database from Google Apps? Now, raise your hand if you have the same question. Well, a lot of them. You have certainly come to the right place. For those of you who have not raised your hand, you're dismissed now. Just kidding. You can ride along. So, first let's look at my data. Now here's, I've got relational database all over the place, and here's a very typical example of an employee table. It's got a primary key. It's got some columns, varchar columns. Every one of the columns is indexed for fast lookup. I have omitted some details of the schema definition to fit this slide. Now let's switch to our database tool to show you my data. It just happens that I'm using Postgres, but any relational database would apply here. So I'm using the database tool to connect to my database on my intranet. And let me just browse to my database called vServer. And it's got a public schema. It's got some tables in there. Actually, one table for our example. The font is a little small, but here's my schema definition and indices and all that. So I routinely execute queries on my database, and here is one of those queries. What it does, it searches employees, the top 20 employees in that database, by using their first name and last name and location. All the ampersand here are wildcards. These are placeholders for parameters we want to plug in later. So let's see how that query works. So I bring up my SQL tool, and I open up the two queries that I have written beforehand. Yeah, this is a little small, but this is the same query that we listed on the screen. It returns the top 20 rows in this query using first name, last name, and location against my employee table. So let's execute that. And here we go. We've got our 20 items returned. And as you can see, I have a lot of data in my relational databases. I like that because relational technology is a proven technology, and it works very well for me. I like the fact that I can execute ad hoc queries on my data, and the fact that I can just set up referential integrity rules, and the database will enforce them for me. So, and other goodness of relational technology. But the problem is my users don't use database tools like I do. Execute SQL queries for their daily work. They don't do that. What they want is easy-to-use applications Most of these apps today are web apps, such as Google Sites, Gmail, and spreadsheets. So we'll see how we can enable my users to be able to access the same data from Google Apps. We'll make a proposal for a solution, and this proposal has 2 steps. First is we will turn my relational data into a standard format. The format is called AtomPub or GData that Google Apps can consume using an open source product called Google Fee Server. And the second step is we will enable secure access to that data in the standard format using another open source product called Google Secure Data Connector. The agent part is open source. And a little bit of a word about AtomPub and GData. AtomPub is an open standard for data format and also RESTful APIs for data access. And GData is Google's implementation of that standard that is supported by many Google apps. And there are client libraries in various languages such as Java, JavaScript, PHP, .NET, Objective-C, to name a few. And we will use those client libraries in our demos today. So we have not invented any new format here. We're just using an existing standard. Now here is the architecture of our solution. At the bottom, I have my relational database inside my firewall. And on the top, I have cloud apps in different forms as gadgets, as App Engine apps, as spreadsheets that I want my users to be able to use against my own data. Now, in the middle, we can see the bridge between the two. The bridge consists of 2 parts. One is Fee Server that translates a relational data into a standard format, like we said before. And the second is Secure Data Connector agent that makes that data available to Google Apps securely to lift up my data into the cloud, so to speak. Now first, let's install Fee Server. And this step I have done for our demo. But on the other hand, it's actually pretty simple. You just go to this site, and the documentation tells you how to download the code, compile it, configure it, and run it. And we'll show you how we have configured it in the next slide. Now here's how we have configured it. First of all, to connect to my database, I need a database role account. So in my dbconfig.properties file, I specify that. I specify which JDBC driver to use. Oh, by the way, Fee Server uses a JDBC adapter to do the translation between relational data, or to do the translation between JDBC, which is the standard Java Database Access API, and AtomPub. So we use that JDBC adapter in Fee Server, and here's how we configure it. We specify which JDBC driver to use, in this case, certainly Postgres JDBC driver, and which database to connect to. The database is on my DB column, that port. Database is Fee Server, called Fee Server. And the database role account is called Fee Server and the password. And also connection pool parameters I have omitted for the whole thing to fit in this slide. And you have full control of connection pool parameters. So as you can see, that as a DBA, my DBAs can create role accounts for Fee Server access. They can limit the privileges of these role accounts and also create different role accounts for different feeds. So DBAs still have full control of what access to give to which part of Fee Server. Next, need to transform my request, the URL request, into a SQL query. Right? This is what we want to do. So on the top is the URL resource/employee search. And with two URL parameters, one is name, one is location. So at the bottom is the definition of that transformation from the request to a SQL query. As you can see here, the select query is what we executed before. And instead of those percent wildcards in there, I have put pound, variable name pound in there so that I can pass these parameters from the URL into it. So for the red ones are basically define the mapping between the URL resource, a resource pointed to by the URL, and a SQL query. So employee search maps to employee search.xml configuration file. And the blue ones are parameter mapping. So the name John will be passed into pound name pound at runtime by fee server to be executed on the database. And next, now the query has been executed on the database, we need to transform the result set back to a response, an Atom response. And here's how we do it. All those orange ones are result set column names. So last name, first name, all lowercase, these are database column names returned by MySQL query. And the blue ones are Atom pub property names. So here I do the mapping. Although I'm only changing the capitalization, in reality you can do whatever kind of mapping you want. You can change first name to given name or whatever. And the green is a hash map. It's a generic data type that we use to store the result set so that we don't need to do any programming on the server for this demo to support this kind of any kind of queries. Now that we have configured our fee server, we are ready to test it. Now we run this query against that curl is basically a command line HTTP client that allows us to exercise our fee server. I have already started fee server on my machine in my intranet. Now let's do that query. So let's just copy that. And execute it here. It gives us a bunch of XML. Well, we cannot really easily discern that, so I have loaded that into a file, and so for us to browse in the browser. So let's enlarge this a little bit. So that says it's a query against this URL, and it returns 20 entries there, and the top entry is this. As you can see, the Atom property names with capitalization in the middle, camel case, are what we define for transforming the result set back to Atom properties. And in here, the top entry returned is somebody called Phyllis Aaron. And if we switch back to the database tool, we can see that Phyllis Aaron is indeed the #1 row in there. Okay. So here we have installed and configured and run a fee server, and we are halfway there. Now that we have the data in a standard format, we still need to make the data available to Google Apps. Now, how do we do that? Enters Secure Data Connector. Now, how we install that is we go to this site, and we follow the simple instruction there and install it, which I have done, obviously, for this demo. And what we do next is I need to enable that feature in my Google Apps domain. So my test domain is called junix.net. As an administrator of that domain, I go to this site, Google Apps Control Panel, and I click on this link, activate and configure Secure Data Connector to allow this feature to be usable. So this is one of the examples of multiple control points that we allow you to have your control. Basically, you need to allow that. You need to configure fee server, configure SDCs and different access rules to allow your users in the cloud to access your data. And the next is an access control rule. So this is one simple rule for the Secure Data Connector agent. What it says is, for the user jyang@junix.net from the cloud, only this URL, which is on host, palmtree.corp.junix.net on port 8080, is allowed for App Engine app called java-sdc-io. So that limits by user, by app, and by URL patterns. And similarly, we can do this to allow access from gadgets and spreadsheets, which I have done for this demo. Now, Secure Data Connector is configured. Now, we can run that with that first command. And as you can imagine, I have already run that. And let me see. And the second command shows, allows us to watch the log of SDC. So you can watch the traffic between Google and SDC and see who is accessing which resource. So we'll run that. And later on during the demo, we'll point back to here to point out interesting things in the log. So, okay. So we're just watching the log, and we'll switch back to here later. Now, we have configured both fee server and Secure Data Connector. As you can see, we haven't written one line of code so far. Right. Actually, in this demo, we will not be writing any server-side code. The next is we'll write some client-side code to use the data turned into the standard format and made available to Google Apps. So first, let's write a gadget. Now here's the main code in that gadget. It's a search function that takes a name and location and a continuation function or a handler of data and executes the request to my data. As you notice that the host name and port pattern is what I enabled in my SDC access control rule, right? And the red is still the same as before. It defines the mapping between a URL resource called employee search and which SQL query to execute on fee server. And the blues are the same. Those are parameters on my URL that will eventually be plugged into my SQL query to execute. And the green ones, the green parameters instruct Google to route this request through SDC to the fee server that runs in my intranet. And also signed, well, that's specified by enable private network. And also signed says encrypt the authentication information and send that through SDC to fee server so that fee server can decrypt that and know which user has come to request the resource. So the flow goes roughly, the user would log into, for example, Google Sites, and the login can be integrated with your LDAP through SAML integration for single sign-on. So the user will use exactly the same identity as if inside your corporate network to log into sites, and then go to this gadget we'll demo in a bit. And the authentication information will be encrypted and sent through SDC and eventually to fee server. And fee server will decode that and know which users has come to access the resource, and then you can enforce more ACL rules at that point. So that's roughly the flow. And then the rest of the function, it's very simple. It basically creates a service object. It sets some parameters on the service object. And then it does a get feed on the service object. And then it uses that continuation function to handle the list of employees returned as response.feed.entry. It's an array of employee objects. Now we'll see how well it works. Okay, let's switch to a demo. Okay, here's my gadget. I have already logged in as Yang at Junix.net, and let's do a search. That's pretty good. That's pretty fast. As you can see, that the top row there is Phyllis Aaron from sales, and she's in Building 2 in the San Francisco office. Just for the fun of it, let's switch to the database tool, and then let's say Phyllis has just moved to the Chicago office. Let's do an update here. And if we do the search again, and you can see Phyllis Aaron on the top has moved to the Chicago office. And notice how fast it is. This request goes from the browser to Google, to SDC server, to SDC agent that we installed and run in the intranet, and then to fee server running on intranet, and to my database running on intranet, and all the way back in under a second. Okay, so next let's try some other queries. Let's find all the Johns in the company. Here are the top 20 Johns in the company, and then say let's top 20 Johnsons in the company. How about those Johnsons in Mountain View office? Well, still pretty fast. So that works pretty well. Next, let's see the App Engine version. Now, for the App Engine version, first what we do is we define a Java bean called employee to hold those properties. The first property, I have only included first property last name in here. But the other properties, you can imagine, are defined very similarly. First name, location, office phone, and things like that. Mapping to the columns, atom properties, mapping to atom properties that I have defined. And at runtime, our client library turns those atom properties into properties on your bean automatically. The next code snippet is what I do in a Java App Engine to issue that request to get the list of employees. As you can see, this is somewhat similar to the JavaScript code. What I do here is I create a service object first, then I set some parameters on the service object. In this case, the green parameters instructs Google to use intranet to route the request to SDC, and then eventually to fee server and to our database. As you notice here, the URL is the same as before, and the resource we access is the same. We pass the parameters name and location similarly. And even better than the JavaScript version, we get a list of employee back. Employee is my data type, and I get my data type back directly. So that's pretty easy, right? Let's see how it works in the demo. Now here's my App Engine app running at, as you notice, it's a little small, but java-sdc-io, that's the App Engine app that we allowed in our access control rule, right? .appspot.com. So let's execute a query here. Let's say search for the top 20 employees here. Well, this time the performance is not very consistent. Let's say Let's try again. This time it's faster. Okay, so and all the queries are not cached. So again, the top one is Phyllis Aaron. Right? Okay, so I can search for other people like before, all the Johns, and it's pretty fast. All the Johnsons. Yeah, okay. So that works pretty well too. Now we have written some client-side code, right? Java and JavaScript to enable access to my employee table. Can we make that even simpler? I guess the answer is yes, we can. So next, let me see how I can make that even simpler by going to, say, a spreadsheet. This is a blank sheet. What we plan to do is we plan to put our name here, the name to search for in B1, and our location to search for, if I can spell that, in B2. And then construct that URL and then access the URL and display the data right in my sheet. That's our plan. Okay. So here are two formula that I'm going to use. One is concatenate the string plus B1 is where we will store the value of the name, and B2 where we will store the value of the location into this access URL that we want to use to execute against our data source, a fee server, basically. As you can see, blue, other parameters. And the number here is a cache buster. Basically, we cache data for a certain amount of time, but for this demo to work live, right, when I change data, I want the change to be reflected on the UI immediately. We can put in a random number to indicate this is a new request every time. And the second formula I'm going to use is import XML. It uses the URL constructed in C1 and does that request, and then says, OK, display all the data elements called entity. An entity is a generic term for all the rows returned in my database. So every entity is an employee, basically, in our case. So I'm just going to do that. So let me copy the first formula and then plug that into my spreadsheet. OK. And I'll plug in the second formula. Into this. Oh. Let's see, there's an error. A1, A2? No. B1, B2, that's the value. I'm going to, sorry. Okay. All right, okay. Let's see if we can spot the error here. Oh, yeah, of course. Single quote, convert to double quote. All right. Here's my data. As you can see, that Phyllis Aaron, again, is on the top. And we can search for other people. And those Johns in, say, Chicago office. As you can see, the performance is pretty good. And we can modify the data again. Let's say move Phyllis to New York office. Let's execute that query. Change that in my database. And then switch to my spreadsheet. Oh, I need to change the magic number so that I don't hit the cache. As you can see, Phyllis Aaron has moved to the New York office. Okay. So, in a very short time, I think in about a half hour, we have built 3 client apps to access the same data that is behind the firewall in my relational database. And we can do a lot more than that. Let's review what we have done. Okay. So what we have done is we have mapped relational data to Atom feeds. That's the standard format Google Apps use. And we have connected behind the firewall data to Google Apps securely. And we have specified access rules to control who can access what from where. And we have written 3 clients for the data. And I think it's important to point out what we didn't have to do. Okay, so we didn't have to write a single line of code on the server. We only did the configuration in one file to map requests to SQL query, and then from SQL's result set back to a response. And we didn't have to set up a firewall hole in our firewall, and we didn't have to use complex firewall configuration to allow Google to access my data. In fact, from secure data connector agent to Google, it's an outbound call. There's no firewall hole required. And from the secure data connection agent, you control what Google can access what, when. And there's no special configuration for the 3 client developers, right? One JavaScript, one Java, and then one spreadsheet developer. There's no special configuration for them. What they understand, for example, in Java, I'm just dealing with my Java being a list of employee objects. No, how simpler can you get, right? So they don't know the existence of fee server in the middle, secure data connector, enabling the data for Google Apps to use. It's very simple for them to develop their apps. Then what's next? What we have now demonstrated in our demo is you can write data back to your database. It's fully supported. You can change, you can delete. Those requests will be mapped to update, delete, and other SQL queries. And you can also manipulate and process the data in the cloud. You can execute your business logic in the cloud. For example, when something happens, send an email. When something happens, create a calendar event in somebody's calendar. And can integrate your on-prem behind the firewall enterprise data with the rest of Google Apps. And in fact, next demo will have a Google Apps script demo, which we just introduced recently. And here's Jonathan Rochelle to do that demo.